Welcome back to Learn As You Explore, your go-to place for mBot2 tutorials. If you are new here, I'm a robotics software engineer who loves helping students learn robotics and supporting teachers who teach it. If you're excited to grab the mBot2 or any accessories, check out the links in the description. I've added Amazon and MacBlock links. If you use the links, I may earn a commission at no extra cost to you. Thanks for supporting the channel. Before we get to programming the mBot2 robot with the smart camera, we will need to install the PixyMon app. This app controls the smart camera and lets us select objects of interest and other parameters that are important for smart camera based projects. Just search for PixyMon on Google and you should see Pixy2 downloads from pixycam.com. Select that. And since I'm on a Mac, I'm going to choose PixyMon v2 Mac version. If you are on a Windows system, select the appropriate operating system, download the file, and once downloaded, you can open it. Based on your operating system, you'd have to follow the correct instructions. Since I'm on a Mac, all I need to do is drag this PixyMon icon into my applications folder in the Finder window. And that's it, it's now installed. Now, we're not completely done here, because when you double-click the PixyMon icon, we see this error pop up which says Apple could not verify PixyMon is free of malware that may harm your Mac or compromise your privacy. And the only options you have here are done and move to trash. But since we know that PixyMon is a trusted software for the PixyCam, we can add this as an exception so that macOS knows that we are intentionally opening this application. To add this exception, click Done, and let's go to the System Settings. And in System Settings, scroll down to Privacy and Security. Once you're in here, just keep scrolling down. And since we tried to open the PixyMon app, you should see this alert which says PixyMon was blocked to protect your Mac. Here we can click on Open Anyway and we get the same alert as before. Let's still go ahead and open anyway. Now before you do that, just make sure you have downloaded PixyMon app from the official PixyMon website that I showed you before and not from any other third-party websites. Also, you should only do this for trusted software that you downloaded from trusted vendors. Since that is the case here and we trust the PixyMon app that we downloaded from the PixyMon website, I'm going to click Open Anyway. It asks me for my password, so I'm going to enter that here and say OK. And there we have it. We now have the PixyMon app installed successfully. For future attempts to open PixyMon, it should just open when you double-click PixyMon and should not ask you to add that exception every time. Use the micro USB cable included with the smart camera add-on pack. Plug the micro USB end into the smart camera micro USB port. The other USB end goes into your computer. Once you've connected your smart camera to your computer, open PixyMon and you should see the region where the camera is pointing to as a live stream. For this project, we want the robot to track a green ball. So what we will do is click on the PixyMon window and choose the program as Color Connected Components. What this program does is it lets us select an object of interest and it tracks that as long as the object has the same color throughout. So click on Color Connected Components and place the green ball in the field of view of the camera. Next, select Action and select Set Signature 1. Here you can see that there are 7 signatures that you can set. So if you want to track 7 different objects, you can set each of them. For now, we have only one object that we want to track, which is this green ball. So we'll just select one signature and set signature 1. When you do this, the frame freezes so that you can select your object of interest. What we will do is we will pick a small portion of the ball, click and drag to select a window, and let go. Now we can see that the live stream is back on and the camera is tracking the ball. Even though the camera is trying to track the ball, we see that it's not really doing a great job. And one reason for this is lighting. Currently, I don't have much lighting in my setup. But fortunately for us, the smart camera comes with a lamp or an LED that we can toggle on and off. So let's go to Action and select toggle lamp. That turns on the lamp or the LED that's inbuilt to the smart camera, and now we see that it's actually tracking the ball pretty well. I'm going to move the ball around to see if it's tracking it well, and we can see that it actually does a pretty good job here. Even if the ball is half in the frame and half outside, it still does a pretty good job of tracking the ball. In your setup, the label that PixyMon gives you might not be ball. It is likely going to say S1 or signature 1. The way that you configure what label to give for signature 1 is to go to the settings and then go to signature labels tab and type in the name of the label that you want to give for the signature 1 and then select apply and OK. I can show you the reverse of this. For example, if I go back to signature labels and I remove this, which by default should be blank, and I say apply and OK, I start seeing S equals 1 as my signature label. So because my first signature is going to be a ball, I'm going to call it ball. Say apply and OK. So now that the smart camera knows what the ball is and how to identify it, let's look at what we can use to track the ball moving within the frame. So as you can see, when the ball moves forward or backward with respect to the camera, like this, we see that the ball is being tracked, but it's moving up and down in the frame. And I want you to notice the numbers in the bottom right corner of the PixyMon window. Right now it says 182.96. But look at just the second number there and see how it changes as I move the mouse cursor up and down. As I go up, the second number decreases in value. Forget about the first number for now and just focus on the second number. So right now we're in the 40s, 30s, 20s, 10s, and then we're in single digits now. So as we go up and up, the number reduces, and as we go down, the number increases, and it goes all the way up to 200 or so, a little bit more than 200. So why are we interested in this? We need to know how close the ball is to the robot. And one way of doing that is looking at this dimension of the image and figuring out where the ball is along this dimension. An image has two dimensions. It has an X dimension that goes from left to right and a Y dimension that goes from top to bottom. And the origin, that is the 0, 0 point, is at the top left corner of the image. And because Y goes from top to bottom, it is 0 at the top and is the maximum at the bottom. So as the ball moves up and down in the frame, the Y coordinate of the ball is going to change. As the ball moves up, which means it's getting further away from the robot, the Y coordinate of the ball is going to reduce. And as the ball moves down, which means closer to the robot, the Y coordinate of the ball is going to increase. This is how we can keep track of where the ball is with respect to the robot. We will use this in our block program and display the Y coordinate of the ball on the CyberPi display for this project. Let's now head to mBlock and implement this. Open mBlock and give your project a name. I'm going to call it Smart Camera Y Value and click Save. Let's first add the mBot2 robot. Say OK. And if we look at the blocks that are available in the block categories, we really don't see any blocks for the smart camera. So the way to add the smart camera blocks is to go to Extension and search for Smart Camera. And here we have the Smart Camera extension and it's by mBlock official. Make sure to use the correct one and say Add. Awesome. Now we have new block categories. This color block detect, line label tracking, and event specific smart camera. For this project, we will only be using the blocks from the color block detect category. Let's start off as always by using the When button be pressed to trigger the start of the program. The first thing we want to do is to toggle the light on the smart camera on. To do that, go to the color block detect category and use the smart camera open fill light block. We have only one smart camera, so we'll leave this as 1, and we want to open the fill light, which essentially means turn on the light. Next, we want to make sure that the smart camera is in the color block detection mode. So again, go back to color block detect and use the very first block here which says smart camera 1, switch to color block detection mode. Drag that, and now we can start the forever loop. So go to control and use the forever loop. Within the loop, we want to print the Y coordinate of the object. detected by the color block detection mode. By now, you know that to print anything on the CyberPi display, you would go to the display category and use the print and move to new line block. We don't want to just print the text makeblock. Instead, we want to print the y coordinate of the ball. The way you can do that is go back to the color block detect category and use this block, which gives us the detected x coordinate of the color block 1. And again, you can change the x coordinate to the y coordinate. Let's first bring the block up into the print block, and we'll change x to y coordinate. As you can see, there are other options, like you can also print the detected height of the ball, or the detected width of the ball, or the detected x coordinate. For now, since we're interested in going forwards and backwards with the ball, let's just print the y coordinate. And if you remember that PixyMon had multiple signatures to choose from, this is where you would choose the different signatures. There were 7 signatures in PixyMon, and there's correspondingly 7 color blocks to choose from here. As long as you have signature 1 in PixyMon set to the ball, you should use 1 here. Alright, that's the core logic of our program, but let's also make sure that we can end the program and turn things off before ending the program. Let's use the when button A pressed this time. And when button A is pressed, we want to first turn off the light because we turned it on here. And we want to clear the screen because we've been printing stuff to the display. So to turn off the lamp, go to color block detect, use the smart camera open fill light, but set it to close this time. So this will turn off the light. Then go to the display category to drag the clear screen block. And finally, we also want to stop all the scripts that are running. So go to control and use the stop block, and you can select other scripts in Sprite. So you want to stop the other scripts that are running. Here we have only one other script, which is this when button B pressed block. Save your program, and you're good to upload now. So as always, we'll connect the robot first, click on upload and select upload code, wait for the program to upload, and you're ready. Let's go test it out on the robot now. If you're a passionate teacher and want to make teaching robotics with mBot2 easier, check out the educator packs I've put together, linked in the description. It's on my Gumroad page, and you also have a free lesson pack to check out before you make a purchase. If you've made it this far in the video, please consider giving the video a thumbs up by clicking the like button and subscribe to the channel if you haven't already done so. It really helps keep the channel going. Start the program with button B. Observe that the Y value printed on the CyberPi display increases as the ball gets closer to the robot and decreases as the ball goes further away from the robot. Here are some of my other videos that you may find helpful. Happy programming, and I'll see you in the next one.